Galina, are you ready?
Yes, I'm ready.
Please, you can start your presentation.
Thank you.
Thank you.
So, greetings from Vienna, from the Technical University, and my name is Galina Pascaleva, and as I said, I will examine today the question of what does it take to succeed when we are talking about standardizing data integration. In other words, what conditions are absolutely essential to the standardization of the integration process. So, our motivating example comes from the tunneling and geotechnics domains. Here we can see the final stages of the construction of a tunnel in Austria. However, at the beginning of such a project, we do not have a built structure, but a largely unknown terrain, both above and below ground. We have to survey it, decide on the most advantageous alignment, and make fairly reliable predictions about the behavior of the subsoil during construction and during operation. Here's one example of such a prediction. This is a longitudinal section through the subsoil along the tunnel alignment. And we see indications of different types of rock, geological structures, and even indications of uncertainty. Not for nothing, the caption above the section reads interpretation. So this is indeed the interpreted model of the subsoil that will be used by the tunnel design team. Now let's make it more difficult. Let us suppose that we have two different geotechnical surveys prepared by two different teams and delivered according to two different standards. How do we combine the information they contain in a systematic way? That is, without omissions, contradictions, or duplication. So in order to do that, we will need to know a bit more about data models. So we just mentioned two different standards. Standards, when digitalized, produce data models. However, data models come in different flavors. Here we present one way to organize them from a very pragmatic point of view. So some of them are more general purpose, so they're more suited to translation, while others are very specific to the knowledge in a particular domain, and that's why we would put them more towards the semantic end of the spectrum. And our first example is of a very general data model, that is of the XML language. In simplified terms, it consists of hierarchically organized distributed containers. It allows it to carry pretty much any information, and for this reason, we have placed it towards the translating end of the spectrum. Our second example is of the data model of an online document. It is still rather general purpose. It can contain any sort of text or media, but it places certain meaning into its elements. For example, while we can put a borehole sample into an XML data model, it is a bit more difficult to put it into this type of online document because it imposes restrictions that are foreign to the domain. For example, differentiation between text and media. And our third example is a tiny, tiny excerpt of the AEC data model concerning the geotechnics domain. And we can see elements that carry very specific meaning or semantics. For example, solid stratum, water stratum, and so on. And these elements are clearly meant to carry information about the subsoil composition and structure. They're hardly well suited to another domain, for example, for carrying information about an online document. For this reason, because the semantics of the data model is so specific and unambiguous to the domain, we have placed it towards the semantic end of the spectrum. Back to our motivating example, here we can see how the same domain knowledge is represented in two different data models or standards. The colors indicate semantic similarities between the elements. On the left, we have the AEC data model, which handles stratified structures and differentiates between solid, void, and water strata. On the right, we have the data model of an Austrian standard for the tunneling domain, the ÖGG guideline, which allows more diverse geological structures. For example, it allows the modeling of separating surfaces. So let's have a closer look at these separating surfaces. In the data excerpt that we're showing here, the model of the separating surfaces seems simple. It is represented as a UML class diagram, which hides much of the complexity. However, when modeled in more detail, again in UML or in another modeling language like KX from the automotive domain, we get a different picture. we see that the organization of the surfaces and the orientation, roughness, and infilling material of each of them can or should be modeled. In other words, we see that we can choose how to model our domain knowledge. We can choose the level of detail as well as the aspects we wish to make explicit as model elements. We may even say that we can choose our view of the domain. And this is what makes communication between data models difficult. We often do not know in what ways they differ from each other. So how do we compare data models in a systematic way? And here we present our approach, a common reference frame, or CRF. In essence, it is quite similar to a coordinate system. We can regard the aspects according to which we compare our data models as its axis. The axis of a coordinate system represent grouping and ordering, and aspects of the CRF, they represent grouping, but not necessarily ordering as a restriction. They can, but they do not have to provide it. Of course, a CRF can have not just 2 or 3, but many more axes or dimensions if necessary. And once we have agreed on a CRF, we can start mapping our data model elements to it. That is, we can start calculating their coordinates. And the data model of a CRF is extremely generic and as free of domain semantics as it is possible to be. Therefore, we can place it towards the translating end of the spectrum we discussed a few slides back. But now, let's see how the CRF works with our motivating example. And let's assume we want to translate an IFC model into an ÖGG guideline model. We start with the element IFC solid stratum and map it onto our CRF named subsoil unit. The aspects we're interested in are the substrate, the structure, and the behavior. And therefore, these 3 aspects give rise to the 3 axes. In this case, all axes are discrete and not ordered. And for example, along the substrate axis, we can choose from loose, consolidated, fluid, or gas. Along the structure axis, we have the options of contact, fold, foliation, or stratification. And along the behavior axis, we can choose from compressive strength, tensile strength, geochemical properties, or flow properties. And this is, of course, a subset of all possibilities that exist. And as we can see, we can even map to multiple points along the same axis. So now we have a CRF representation of our element, which consists of all the dark blue points. And if the element has an aspect that is not included in the CRF, this just means that the CRF needs an additional axis. So let us now map all the elements of the ÖGG guideline that cover the aspects we discovered while we were mapping IFC solid stratum. So incidentally, there are 5 of them, and we can map them to the CRF in just the same way we mapped IFC solid stratum in order to determine their coordinates. And now we can see the corresponding elements from both data models with their respective coordinates in the same common reference frame. So let's compare them, but this time systematically. So the dark blue points indicate semantic overlap. The light blue points, information in the Austrian model that has no corresponding elements in the IFC. And the purple points indicates information in the IFC model that has no corresponding element in the Austrian guideline. And now, armed with this knowledge about the similarities and differences of the 2 data models, we can proceed with the data integration. So we can see here an additional function of the common reference frame. Not only is it a tool for systematic comparison between data models, it can provide an integration mechanism as well. So first, where there is semantic overlap, it provides either direct information transfer or a transformation from one model to the other. For example, if one model represents movement along a separating surface as a 4x4 transformation matrix, and the other as a translation vector and as a quaternion for rotation, here within the blue points is where the necessary transformation is performed. Second, where there is no possibility for transfer, the light blue and the purple points, the information can be held temporarily while processing of the transferable information is happening in the other data model. And third, there's something we haven't talked about. What about contradictions? What does a contradiction look like in a CRF? It could be a contradiction of semantics or views on the same semantics. So therefore, a contradiction would manifest as a disagreement on the existence or separation of aspects and would not allow the construction of a CRF in the first place. So it would necessitate communication between the domain experts, because not the data engineers, but true domain experts can solve such a problem. The plus side, any contradiction will be discovered and resolved before even the first step towards data integration has been made. That is when we can act with as few restrictions as possible and have as big an impact as possible. So that is the end of my presentation. Thank you very much for your attention.
Is there any questions? Yes, please.
Hello, my name is George Marino. I'm in the University of Cambridge. It's more of a comment than a question. And I feel like here we are kind of comparing apples and pears because you're comparing meta models with semantic models like IFC. And the example is with XML, for instance, is not a model on its own. It's more like a meta model that is meant to be used to design other models. So I feel like this work is meant or is done in kind of false assumptions. I'm not trying to roast the work whatsoever, because I think that you've been doing a great effort on comparing to some other models along the spectrum. But I feel like your work should include like a comparison of what's a conceptual model, like IFC, for instance, and at the other end of the spectrum, what would be a logical model. So it's when you're, let's say, implementing that conceptual model into a technology. I think that's not only your false assumption. I've seen that in other works this morning as well. So maybe because I have a completely different background, I'm knowledgeable about this, but I feel like maybe in this domain you want to include that vision as well. Should take that into consideration, or if you have done that, Galina, please let me know, because I'm maybe also getting the false assumption. Thank you.
Thank you for your comment. It is actually quite significant what you just said, that there are, I come from the domain of meta modeling, so I'm very much aware of the meta modeling stack and that there are meta models and meta models. But my experience with domain experts is that quite often there is a necessity to be a leveling as a model level agnostic, just to forget about what level we're at, because people tend to work in different models and tend to require transformation between different meta modeling levels. So this is a more generalized approach, but you're quite right that when implementing this, one should pay particular attention to at what meta modeling level one is at, so that there is no confusion and we're not, for example, translating between types and instances.
Yeah. So my specific example was with the comparison between XML and IFC. Because you can use XML to actually implement IFC. So it's not fair to compare the two, because one is a meta model, the other one is a domain model. So you could compare the same, let's say, model if you've implemented, let's say, IFC using different technologies, because you could compare XML to JSON, but not to IFC or let me say other domain away for buildings, right? That's what I would. If you want to take away the meta modeling out of this comparison for your work. That's my point.
I would argue that IFC combines actually conceptual and domain modeling, because IFC has some very abstract parts of it. For example, the whole proxy system. So we could, of course, actually, this is a very interesting study to examine I'm sure we can implement IFC in XML, but I would argue that we can implement XML in IFC.
No, of course you cannot do that because
Oh yes, with proxies.
It's meant to be a generic data structure or meta model to model data models. As you said, UML is as well. So you could compare
Yes.
UML, JSON, and XML, but you cannot compare XML with IFC because they are completely different things.
Well, we have to agree to disagree on that because I would claim that IFC contains both meta modeling parts and domain parts.
All right, then if I may suggest you go and look into conceptual data modeling, logical data modeling, and physical data modeling, and then maybe we can agree.
Thank you.
Yeah, thanks for that. I think that would be good to have these types of discussion during the conference. So yeah, please do follow up. You guys follow up the discussion. I think that would be great to have some more further development or improvement for the research. Thanks for that. So I would like to introduce another presenter, Jordana, to come to the stage to start the presentation.
Best.
There should be a clicker there on the table that you can use.
Okay, hello everyone. I'm going to present my research, which has a title, Guidelines for Managing Customers Complaint in the Real Estate Market. Companies usually receive customers' complaints during the builder liability period, and those records must be used to support feedback process. So customers' complaint represents a learning opportunity and should be properly managed by companies. Unfortunately, those records are not managed properly by companies. There are several problems, meaning in terms of data collection. So complaint databases are often incomplete and have poorly structured data. As a knowledge gap, most previous studies on defects on customers' complaint refers to facility managed context, but they are concerned about improve maintenance plan and not about improve further design and production process. Also, they focus on analyze large database, generating some indicators to improve the maintenance plan. However, the knowledge generated is limited due to data limitations. So there is a lack of discussion on how to improve the quality of records. So this study aims to propose guidelines to collect and process data on customers' complaints in residential building companies. This study adopts design size research because this type of research seeks to create an artifact, devise a solution. The artifact of this study refers to guidelines to collect and process customers' complaint data for real estate companies. And this study have been developed in partnership with a Brazilian building company. It's considered a leading company in the implementation of lean production practice in Brazil. Also, this company has a warranty service department, which receive the customer complaint during the builder liability period. So provide the repair service currently to around 30 residential projects. So this research was divided in 3 main phases. In the first one, we carried out an evaluation of the warranty service. So you used 3 main data source, source of evidence, such as participant observation, interviews, document analysis. So as a result of this first phase, we carried out a diagnosis about the warranty service process. And then in the second phase, we propose several improvements, mainly in terms of data collection. So for instance, we propose new variables that the company should be collect. And also we suggest some new structures of current variables. In the third phase, we propose implementation of the improvements. So we carried out a new data collection during around 16 customer service using a digital tool. It's basically a mobile application that we developed. So in this slide, I have the four main phases of the warranty service. So in the first one, the company received the customer complaint by a phone, by a website, and this this information is recorded in the information system in text format. If the defect is covered by the period, a technical inspection is scheduled. The technicians in general collect data using a paper form, and then the repair service is done. And then you have the feedback process, which the company of this study gather all sectors to discuss the problems. However, those problems is not based on the customer's complaint database, but based in perception of the technician about the serious problems. This happened because the database has a lot of problems about the lack of quality of the data. So as problems and opportunities to improve that process, I would highlight four. So the first one is the inadequate data structure, because in general the data is in a text form, so it is difficult to analyze. You need to put a lot of effort to process. The second one refers to defect categorization system adopted by company. In general, the categorizations, there are ambiguous categories and generic categories, which means that these categories don't have enough details to know what is the causes of the problems. The third refers the rework test, because company use paper form, so we needed to store this data in an online database later. And the last one refers the loss of essential data, of course, because the company doesn't collect important information, such as the cause of defects. Okay, so here we have a table with a comparison between the database as is, the database of the company, and the database which we are proposing, the database to be. So of course, here you have just the stage of inspection, but we are proposing variables to other phases too. And in general terms, we are proposing around 34 variables, while the company's database has only 15. So it means that our database are more complete. Here we have some interface of the mobile application that we developed during the study. And these interface were divided according to the warranty service process. Here we have some interface in more detail. So, for instance, in the first one, the technician can take some pictures about the defect, can record the location, the floor level of the defect. And the second, the third, the technician can categorize the problem according to the system, the element, and the compound of the building. In the third one, the technician can collect the causes in a systematic way. So as a conclusion, this study proposes improvements in complaint data management in real estate markets. So for instance, we propose a set of variables and their structures also was proposed. We propose a mobile application, we develop, test it, and also indicate some recommendation about its use. It's more details in the paper. And the empirical study that you develop evidence the benefits, so we improve the quality of the data. As limitation, we did a small data collection due to the time limitations, but you are extend it. And finally, the digital tool has only the data collection form, but we intended to extend it to create a dashboard module to visualize the key indicators. That's it.
Any questions?
Thank you. Hi, Jordana. Patricia Zorzopoulos from the University of Huddersfield. Jordana, would you like to expand a little bit on the method of your research, just to explain a bit more how you got to the data and what you've done with it? How is that going to help you achieve the results you've intended?
Do you mean how I intend to continue the data collection? Yeah. It is actually is a problem because I try to collect more data, but the customer service has a long time to resolve the problem, around 1-2 weeks, depend on the defect. So to collect one data, I should follow the customer service 2 weeks. So it is impossible to gather a lot of data to analyze after. So now you're trying to adopt a different method. We try to use the current database of the companies, and you do some workshops to collect the data from the technician perceptions about the cause of the problems. So in the end, you have the implementation in a weight scale just about the causes and not about the other variables. This is a limitation, but we find to solve in this way.
Thank you very much, Jordana, for the very interesting presentation. I think it's an important topic, and my question is more on the points that you mentioned. You're doing your study in collaboration with a specific company, right? So my question is, what are the perceptions of the company from you've identified that the way they captured data was not very good? So this is the first point. And the second point is if you've already had discussions with the company in terms of what they're planning to do with the database after you have that. Because my understanding is that you are kind of creating a very important information repository that the company can use in many ways. So I just would like to know if they have any clue on what they're going to do with the data later. Thanks.
Yeah, we are developing this study in a little sector in Porto Alegre, and this company is in national. This company has a project in all a country, so it's a little difficult to the manager. The manager is so free-minded, but it's a little difficult to manage. Open more doors to implement in a wide scale or research, because it's difficult to talk with the high positions. So they know these barriers. And about the database that you are trying to create, they are waiting good results because now they don't use the data to feedback process. So they are waiting to use the database during the feedback process in the further meetings of the feedback process. So you try to analyze the data and propose some indicators.
one last comment is, do you or will you consider some theory while you study? Yeah, any theory behind your study? Because I suppose this is your PhD study, right?
Yeah, it's my PhD student. Yeah.
You don't need to give me an answer right now, but you need to think about what are the theories.
Yeah, this is a big question. Actually, my study is more connected with the practice, not the theory. But yeah, you consider that and try to connect some concepts, maybe about some taxonomies of the facts, how organized that the information I can find in literature, and these are doing.
That's the typical question.
Yeah.
Okay. Thanks for your presentation. Well done.
Thank you very much.
So we have the next presentation online. The presenter is Wilco. Wilco, are you ready?
Hello.
Hi, nice to meet you. How are you?
I'm fine. And you also doing fine?
Good, good. So you can share the screen.
See its functions. Sharing. Good function now.
I can.
Probably you can do it on your thing because it seems that it's.
You share. Okay.
Yeah, let's wait. Probably wait. And probably I can. Let's see if the thing goes proper based. Up. Check.
Yep.
Yeah. You have it? Yeah, right.
Hey, Wilco, just give me about like a minute. I'm just going to download it for you and I'll flick through it for you if that's all right.
Yeah, okay.
All right, 1 second.
When you are, Will. Yeah, it's all done. So you can start your presentation, Wilco.
Okay, great. And you can all hear and see me, I guess, eh? So that's yeah, great. Yes, thank you very much for giving me the opportunity to present today. I'm presenting from the Netherlands, so for us it's now 8 o'clock in the morning. For you it's approximately 4 o'clock afternoon, as far as I've understood. Today I will speak about building our future and the future of building intelligence from an organizational cultural viewpoint. As one of the joint coordinators of CIB W112 Culture in Construction, we look more in depth to developments, what's happening with human behavior in construction industry, cultural business, cultural background, and so on. Yes, next, please. So this is the menu to speak about. The proof of the pudding is in the eating, we always say. So first, have a short introduction. Then about acceptance of technological developments within construction industry itself, some Dutch examples of housing industry, changing stakeholder behavior, people's business as to be announced, organizational cultural influences within construction improvements, discussion and conclusions and recommendations. And as you will see also in my paper, it gives some considerations about actual developments, and we try to highlight that and also use them for further research also within our W112. Next, please. Yes, speaking to actual times, we have quite dynamic times, and we come, of course, from crisis times, from COVID, etc. Now in war times, looking from European perspective with Ukraine and Russia. And all these kind of developments do continue to influence society, not only, but also, of course, construction industry itself. Because from our viewpoint, the construction industry is more or less reflecting developments, what's happening around us, and also if give a kind of, say, way how we build, how we live, and what it means for built environment and the way how we approach that. And so they are going really fast, all these kind of developments. It's not only negative, it's also a positive point, but we come more back into that. Look to what happened in the pandemic time. Medicine developments have been speeded up so fast as it was never before. Normally it took about 10, 11 years to get a medicine to the market. But due to COVID, it was about within half a year, 6, 9 months. So things moving forward, not only in high tech or high technology bases as often considered, like information technology and so on, but also construction itself is moving forward. It might, in some cases, this always thing that people sometimes say it's a quite low-tech development or low-tech industry, but it isn't. If you look more deep in what construction uses from developments around the world, it still needs quite high profiles to use it properly. And not only from going forward in a kind of new development, but also kind of drives to survive. Because the users' demands, and that is an important factor which we consider as one of the most important factors in industry, user demands are changing. If you look for an example to infrastructure, or at least probably look from at buildings projects, and coming from a European perspective from this kind, we see an increase of working from home. Today, exactly, I'm now not in Australia, but I'm continuously easily connected to your and the room. And so it don't need especially to travel that far. Of course, it's not in the positive way in a sense, because meeting people in person is always better and always give better interaction. But nevertheless, for those things which have to be done from a certain perspective, it works really properly. And so that also leads to different ways of how to design the buildings, how to use properly infrastructure, or maybe even less use infrastructure, which also gives them, of course, influences on planning and spatial infrastructure and so on. And so these are kind of things all about technology, but if developed, you have also overcome the acceptance of its users themselves. So you see here, I put there a kind of diaphragm and people around it. And so if you look as a symbolic explanation, look from the left to right, and that is one light beam goes through a diaphragm, but you can see it consists of several different colors, several different tastes, several different aspects, which is not that always easy for everyone to accept it as it seems to be. But nevertheless, it's somehow you need to cope with that. Next, please. When you go then more into deep and in that acceptance aspect, and you look more or less to those technological developments, and you can distinguish several ways of what people are questioning. And we see it also in researching about building cultures and so on. And if want to change, if you need to change, many people might ask, why should we do it different? Is there a reason? Sophisticated technologies increase risks. It's not always easy to overcome those risks, and that is a kind of maybe entrepreneurial spirit even to accept them. And so it's doing things new is not always felt as being necessary, and more or less it's even more felt as being threatening. If you other ways look around, there are also people who say, wait a minute, if we use most innovative technologies, and what is most innovative technology, or what are more innovative technologies, nevertheless, it makes us the best in class. And that's also an assumption which you often see in discussions. And so being at the front line of what happens makes a kind of, say, positive feeling about development. And that is, of course, also what drives forward science. And that is always a challenging thing, to have the possibility to be on the front line of developments. But also, another thing, people are changing. If we look to our younger students, look to our students in general, also young people, new generations, they are being grown up with most modern technologies compared to our elders and parents. And so, in fact, the technology levels are more or less causing also attractiveness, or even one of the attractiveness aspects of attracting people to your company or to your business or to your research. Whatever happens, you want to feel that something happens, something is developing, something goes forward. And so there are all things which are challenging, which are also considering, but also which are influencing acceptance of technology and development itself. Looking then more in the built environment, You see increased attention for so-called bio-based building. Every one of you might see it around you. You see an influencing of CO2 levels, which are reducing probably or increasing the risk of say, negative aspects of nature. Also pollution. Now think about it. And that are things which still are increasingly happening around the world. And so that, say, awareness of that we need to do something with our cyclic thinking of materials, of concepts, of design, etc., is now really getting foothold in the market. And if we speak 20 years ago, 30 years ago, many aspects had to do with open building and all those flexibility, which is still much, much important. But nowadays you see that cyclic approach of construction materials, construction building, which absolutely are influencing now the total approach of how we build our and design our environment. Next, please. To give a short looking back at these kind of examples, it is not nowadays only where it started. And if I look here, there's an example of the 70s, early 70s. There was in the Netherlands where a German professor or Austrian professor, which all in those days already published about biologische Architektur, as the Germans done, and so biological architecture. And he always discussed it about the method of holistic participation. And so looking to everything with everything, and everything influences everything. And that is, in those days, it was quite seen as alternative. I was taught also by this professor in one of the later years, and it was really a kind of, say, guru in this way of thinking. But it was always considered to be something strange because it was not mainstream. It doesn't need to be in a sense that it goes that way, but what you see that a lot of different things, different thoughts in the industry are probably considered now as something strange at all, but you must be prepared that it may be in later times, the momentum is there and that things, and like a puzzle, everything falls in place. And also here again, this prism, as I explained to you earlier, this presentation, that multifaceted approach of different aspects of theories, of approaches, of science, and so on. And you can think about it, but there are always aspects which might be getting more prominent or less prominent during certain times of development where we are in. Next, please.
So
this is also one.
Sorry, you have 1 minute left.
Oh, that's very shortly. That's very short. Sorry. This is one also as an example from a development stage. This is quite traditional in those days, but not with technology influence for IT and so on. The next one, please. We can also go on. Standardized housing types as being actually now in the development, where you see the assembly as a series of one house in a day. It's an important thing. Next, please. I will go now jumping somewhat faster. This is an example also, but you can read all in the paper and give some more better examples. Now we go to the next one. Yeah, here you see, in fact, the graph, which is quite important together with the other one, and that in fact business is going forward, and so why to improve, those kind of thoughts are, but in fact more or less we should be aware that we have to repair the roof when the sun is shining, so that anti-cyclic thinking of improvement and not always be prepared to change and to be able to move forward in a development in the market is absolutely essential. Next one, please. You see it here also, where in fact the crisis-driven developments are added to that, and that makes it that this whole graph of the previous slide is getting more higher level, and so in the paper it will be more explained. But you see the need for, say, orientation and realization, but also looking back and looking forward, and those crisis influences are really making people moving forward, at least have to decide to move forward in a sense that which might be able to help them. Next, please. And so in these kind of developments, you always have to take care of that there are crises, there are negative impacts, but in fact it will help us and it will make us aware that if things have to be done different than at that moment. So the value of a crisis is more or less than he explained properly, and in the paper it gives more examples of that. And so next, please. And so that new reality is for people, many people, threatening, but we should be aware that it also gives an opportunity, and it not only for it's now or never. I put it there as a kind of statement, but it will make that people getting more open and will be getting more accepting that how we change. Then we have to change and look into data, or behavioral data, which is often being said at new gold, but in the end, it's people's business. Last slide, please, with conclusions. You see here, and the conclusions about that. Analyzing it properly, being aware what's happening around us, and being also hands-on driven, not only if technology is looking at it, also in behavior. In the last slide, or previous last slide. Next, please. Yeah. Listen carefully to what clients want, and it seems quite logical, but nevertheless still necessary to keep in mind, because success in business creates a risk that organization become increasingly deaf for the client's weak signals, and those weak signals are more around the world, not only by social media but also the facts around us, and that should be a kind of a driver of being alert, basically also for our students to be alert, and also to push research forward in the direction which are helpful for not only for our generation but also for next generations. Next slide, please. Thank you for your attention.
Thank you very much, Wilco. Is there any questions?
Hello, Wilco. Thank you for your presentation. My name is Yi from Griffith University in Australia. It's very exciting to see that you highlight the importance of humans in the construction industry. I strongly agree with your ideas, even though I am from a quantitative data-centric background. Because recently when I was looking back at the most emergent technologies like BIM and blockchains, all these technologies seems to highlight that we should focus on early engagement of different stakeholders to maximize the benefits of these technologies. And in your research, based on your research expertise, do you think there's a way or some solutions that we potentially can leverage technologies to support this human-based construction?
Thank you for your question. Yes, I absolutely convinced that if we are not taking into account the users in a very early stage, and users can be very broad, you have those ones who are directly involved, and you have those ones who are more or less being stakeholder, who are influenced by the use by others, and that makes it absolutely necessary to be more successful, to be more directive in the way how development should go on. And I published, for many years ago, I published also a paper together with Hong Kong University, Isabel Chang, about how the ICT acceptance is being influenced by the user themselves. And because that is, in a sense, that is, in fact, the key factor to make technology plausible, and not only at one end, but also make it effective and also successful. And that's always a discussion between, say, the quantitative approach, which is very hard data driven. That's also necessary because you need to have background information and so on. But that more soft factors, which is in fact the interface between the user and the tool, that is in fact in many cases the decisive factor which makes it successful or not. And being aware of that aspect should be probably better more, say, spread the word around, and we try to do that, of course, also with our research, and it always proves to be a right approach in a sense. And of course, we're open to discuss that more in detail, but it will help, and we do not only see it in the region where we did our research in a sense, but you still see it, in fact, on a worldwide scale.
Yeah, like a follow-up question is, and to me, it's like it seems like those coordination and early engagement and communication issues, they are much more difficult to implement than simple technology implementation. And what do you think?
Yeah, that is absolutely challenging, because you have to to know what really goes on in a sector where you want to implement. More or less, you have to undertake probably some more partly participative research so that you are able to understand what's really happening inside and also translate that to what is really needed to improve what's happening there. And that is a vice versa situation, and that is absolutely challenging, but it's not impossible, because if things have been implemented and are less successful, that data and learning data coming from those, say, failed implementation will help you to improve the next steps. But it will speed up if the moment you know what is really, say, or what are really the barriers or really the necessary aspects which should be provided by the tool. And so in the end, say after whatever long time you take, somehow things will improve, but you want to speed up and you want to be faster successful, because parallel to the improvement, also situations already change again, so that models or tools you are developing should also be then quite adaptive to that new situations. And that is in fact, and like you say about it, it's a dynamics in a dynamic world.
Yeah, thanks for that. Thanks for that. So I do expect that similar discussion can be continued, outside this the talk. Thanks for that, Wilco. So we are having time constraints, so I would like to invite Asim to come to start her presentation. So thanks, Asim. Yes, please.
Hello, everyone. Thank you for coming for this session. I'm Azam Zahori, and today I'm here with Mustafa, the Prof. Monty Satrisna, and I want to present this paper. The title is Comparing two AI Methods for Predicting the Future Trend of New Zealand Building Project, Decision Tree, and Artificial Neural Network. Next, please. The outline of this presentation, I started with the short introduction, literature review, then I will explain about my data set, methodology, result, and conclusion, and it follows by acknowledgement and reference. The introduction. Artificial intelligence and machine learning are applied in different aspects of the construction, and this trend happens in many construction sectors, including New Zealand, but New Zealand is relatively very small compared with other countries, and small and simpler for the complexity. They're not very complex, but they have their own unique characteristic in New Zealand. The current study aims to determine the suitable method for building consent issued in New Zealand based on publicly available data. This is the literature review. In the literature review, we speak about disruptive technology in construction, such as artificial intelligence, big data, cloud computing, Internet of Things, blockchain, AR, VR, with the main focus on the artificial intelligence techniques that they applied in different research in construction. This is the data set that we choose. We got the data from the statistic NZ, and it was 5 different files that we try to combine them all together and in one data set, and then we actually combine them, clean the data, and make suitable for the data analyst. As you can see, it started from 2016 to 2021, and it's related to housing, apartment, retirement, village unit, and so on. All of the data available as a public domain. Methodology. We have 2 AI methods, decision tree and artificial neural network, that we applied. For the programming part, we use the Python language for programming for the prediction, and for the visualization, we use the Power BI. For the methodology, we divide all the data that we have to different set, training set and the train set. The training set is 70% of our data, and the test set was 30% of our data. We train our model based on the training set, and then we apply the model on the test set to find the accuracy of the model. And also on top of it, we try to validate our data to see that the model working correctly, and we use the tenfold cross-validation method for validation of the method. As you can see, this is the Power BI visualization for the whole building consent information, and we have the prediction in the end. This prediction is related to artificial neural network for 6 months after the whole data that we have prediction for the future. And the decision tree, they give us the good answer for this kind of data. It was under 50%, that it wasn't actually a good result for prediction. We are not considering that. And this is the a small part of the big project that we have for predicting the capacity and capability, and it's a part of that research. For the conclusion, I want to speak about mostly about the limitation for this study that we have. First, the data are from 2016 to 2021. It's 5 years of data. It's not enough for finding the pattern in the data. And also 2 years of these 5 years we have the COVID-19 situation that it affects the pattern of the data. And if we have more information and more years of the data, for sure we can find a better pattern recognition for prediction. Part of our research that comes from the Ministry of Business, Innovation and Employment, MBIE, and we want, as I told before, we want to go through the capacity and capability prediction. That is the reference, and thank you.
Thank you very much. Any questions? No, online.
I'll be the bad one.
I have conflict of interest.
Okay, thank you. So it's good enough for a first year PhD who's standing here and presenting the first work. But my question would be, could you please summarize in a few sentences what objectives you're trying to achieve in your paper?
For the reason of the capacity and capability, that is the big project that we have to go through the pipeline project that is happening in the future, and we want to know that what is the capacity of the future work in the pipeline for the construction, and we try to apply this kind of method to see which method is the best method that can be applied for prediction in the future. For example, for here we can see what is the number of the building that want to happen in 6 months after the end date of the data, and then based on that we can see what is the capacity of the market plus other building that happening. For example, is not just included in the residential. It should go for all of the different kind of data that we have, and then we predict for 3 years, 5 years from now, and then we can see the trend of future. Do we have enough contractor? Do we have enough material for that time? And get prepared for the future.
And then in this case, could you please define the term capacity? What do you mean by capacity?
It means, do we have enough people, a skilled worker? Do we have enough material? Do we have, for example, if we have a big project in a small city, we don't have a capacity of the people who work there.
Okay. So then, because you use the two different AI models, then what's your input and what's our output if you're taking the resources? What are you trying to measuring?
Yeah, the AI method working like you have a training set and the method get learned from your training, and then you put it based on the test set. Then you actually compare the training and test to see that am I understand it well? When you have the result, then you can go for more prediction for the future. It means your model.
Then what is your X and Y in the models?
What is my, it's like the table that I show you, all of the data that we collect based on the statistic inset. This is my input. And
so your input is the, for example, the number of resources and etc.
And the output is the same, but for the future.
Is that supervised learning or unsupervised?
It's the supervised learning.
But isn't that for the, isn't it your output for the future? How do you get it supervised then?
What do you mean by supervised?
Supervised learning means that you have already got a data set that has been labeled with correct answers. If your Y or your output is the future capacity, then how are you going to do supervised learning? Because the Y, the future capacity is unknown. That is, so it means that the Y is unknown, that you can't do.
We have a model there that is learned from the.
So trained is at 75%. So you use 75% of the data set to train, and you use the rest to see if you want.
Yes, but the Y, but when you're saying the output is the future capacity.
No, we're not talking about the accuracy of prediction. We're talking about how is the model predicting what the future trends are showing right now. So we've got two different methods, and we're looking at the differences between the two different methods. It's not about the accuracy of the future prediction. It's about the accuracy of the two different methods.
So when you say future trend, you mean, for example, your data was collected in 2015 and the future means that 2021.
Yes.
Okay.
So it's a 5 years from 2016 to 20.
Now
and
here we try.
Why would you need two AI models to do that? Is there a way that you can do, for example, linear regressions, simple ways to do that rather than use this fancy term called artificial intelligence?
Yeah, for 5 years, yes, we can use this kind of the method, but the data will go more and more and more than that for the future research, and we want to apply all of AI method to find all of the pattern, and we want to go through the IT for the future. We don't want to sit and use the regression of it.
Trying to the best way to do the regression. Yeah.
Then what is the meaning of pattern?
We want to find the pattern in the data. The pattern is like the method in the back of the data, try to find the pattern and make it like a formula for the method. And then we apply that method that AI created to the test set.
And I just want to make it from my side. No, so the huge problem with capacity is that it's very non-deterministic. Got so many things, and we have a lot of problems in terms of predicting the actual variables. So we don't even know what the input should be at at the moment, the best way of looking at it is a different black box methods that they are Bazzan. What we're trying to do is not trying to be deterministic at all. We're trying to be looking at if the model can be predicted, how it can be predicted, and what's the best way to say that these trends can be predicted. So it's basically trialing and error in different types of modeling strategies, rather than saying that, oh, this is our inputs, this is our output, can we predict the inputs and outputs?
Okay.
So it's more to see what fits best at this stage.
Yeah.
Then we could look at, yeah, you're absolutely right. We need to look at what the input predictors are, what the outputs are, but we don't know. That's the problem. But we're relying on other teams. This is a 5-team program. We're relying on other teams to tell us what the predictive variables are. So in the meantime, we're not just staying put, saying, okay, we need your input. We're trialing our own modeling technique.
And then in this case, what might be your next step?
The next step is to see variables.
Anyway, thanks for that.
Yeah,
I like this kind of discussion as well. Because we are running out of time, so perhaps I would like to close this sessions. Final question: is there any question online from anyone online? No. Okay. So anyway, thanks for coming this sessions. I hope you can enjoy all of this discussion in this session. So thanks for that. Thank you.